Okay, the intersection of lines and circles. So some examples of problem solving here. You'll remember that this is quite similar to the parabola stuff. So hopefully this is familiar, but I'll go over it anyway. You've got your three situations here. You've got no point of intersection where the line and the circle don't meet at all, 2 points of intersection, or 1 point of intersection where it's a tangent, okay? And what we need to remember to prove these is it's all about the b squared minus 4ac. Remember the discriminant. If you can remember back to last year, if it's intersecting at 2 points, then that means that when you use the quadratic formula, you will have two distinct answers. And in order to get two distinct answers, b squared minus 4ac is greater than 0. So if we have b squared minus 4ac more than 0, we have 2 points of intersection. If it's equal to 0, then it doesn't matter whether you add it on or subtract it, you'll get the same answer both times, which means you're only getting one answer. So if b squared minus 4ac equals 0, then there's 1 point of contact, and that makes the line a tangent. And if b squared minus 4ac is less than 0, then we can't take the square root of it, so it won't work. You get an error in your calculator, and that means there's no point of intersection. So applying that to the circle is exactly the same. So we're interested in our quadratic equation and our discriminant. Okay, so let's get started on some examples. So first of all, does the line y equals 6 intersect the circle x squared plus y squared equals 25? So there's no real way to begin this, but we have a value for y and we have an equation, so let's substitute it in and see what happens. So x squared plus y squared, which is 6 squared, equals 25. So x squared plus 36 is 25. So x squared equals negative 11. Now you know that the answer to a square cannot be negative. Can't take the square root of a negative, so therefore this won't work. So it doesn't intersect the circle at all. So no real solutions. So y equals 6 does not intersect circle. And if it made sense, then it would. Okay, next problem. Find where the line y equals 3x minus 10 intersects this circle. So what we're doing there is we're going to sub in the value for y into our formula, tidy it all up, and then see what happens. So I'm going to change y to 3x minus 10. So rewriting the equation of the circle, x squared plus y squared. But instead of y squared, it'll be 3x minus 10 squared plus 2x plus 6y's, but again, changing my y, minus 10 equals 0. And now we just tidy up. Now let me talk about the squaring. There's quite a lot of squaring going on in this video. So I'm going to show you the long way of doing it and then the quicker way of doing it. I'm just going to do that over here. So if you've got 3x minus 10 squared, that means 3x minus 10 times 3x minus 10. So 3x times 3x is 9x squared. 3x times minus 10 is minus 30x. And minus 10 times 3x is another minus 30x. And minus 10 times minus 10 is plus 100. So it's 9x squared minus 60x plus 100. Now that method will always work. And if you prefer to write the two brackets out twice and multiply it all out and tidy, that will always, always work. But if you notice that what we've got here is if we take our 3x, minus 10 squared, our question up there. So what we've done here is we've squared the first thing. So squaring 3x gives you 9x squared. Then we've taken twice the product. So if you do 3x times negative 10, you get negative 30x. And if you take twice that or double that, you get negative 60x. And then if you square the last thing, you get plus 100. So a quick way of doing the squaring of brackets is square the first, twice the product, square the last. Okay, but you must remember that twice the product part. So square the first, twice the product, square the last. And if you're comfortable with that, it will save you a line of working, and it's completely fine to do this method. There's no problem with missing out working. So I'm going to do the quick method, but if you want to, you can just write them out twice and multiply. So x squared plus square the first. So the square of 3x is 9x squared. Twice the product. 3x times minus 10 is minus 30x. Twice that is minus 60x. And square the last. Negative 10 squared is plus 100. Plus 2x. And then 6 times 3x is 18x. And 6 times negative 10 is minus 60. Minus 10 equals 0. And then we're tidying that up. So my x squares, I've got 10x squareds. I'm just going to score them out to make sure I've counted them. Then my x's, I've got negative 60x plus 2x plus 18x. So that's negative 40x. So that's them done. Then I've got 100, take away 60, take away 10, which is 30, equals 0. So then remember, when you're factorising, always look for a common factor first, no matter whether it's quadratic or difference of two squares, just take out that common factor first. So I'm going to take out the 10, leaving me with x squared minus 4x plus 3 equals 0. And then putting that into my two brackets, numbers that multiply to give you 3 and add up to give you negative 4 are going to be minus 3 and minus 1. So that means my answers are x equals 1 and x equals 3. So those are my x coordinates for where the line will intersect the circle. So it's intersecting it in two places here. So I've got my x coordinates. Now I need to find my y coordinates, and I can use this nice equation here. So when x is 1, y is 3x minus 10. So 3 ones minus 10. Which is 3 take away 10, which is minus 7. So that gives me the coordinate 1 across minus 7. Then when x equals 3, y is 3 threes minus 10, which is 9 take away 10, which is minus 1, giving me the coordinate 3 minus 1. So that's the two places where this line will meet this circle. Okay, next one. So prove that this is a tangent to the circle. This line is a tangent, and then find the point of contact. Okay, so first thing is to prove it's a tangent. So let's sub it in and then see where we get. So let's rewrite our circle equation, substituting in 2x minus 4 for the y. So x squared plus y squared becomes 2x minus 4 squared minus 2x minus 6y's plus 5 equals 0. So x squared plus square the first thing. So 2x squared is 4x squared. The product of 2x times minus 4 is minus 8x, so twice that is minus 16x. And square the last, squaring minus 4 is plus 16. Then the minus 2x and minus 6 times 2x gives me minus 12x, and minus 6 times minus 4 is plus 24, plus 5 equals 0. So my x squareds, I've got 5x squareds, so they're done. Then my x's, I've got negative 16x minus 2x minus 12x. So that is minus 16x minus, so that's minus 18x minus 30x. And then 16 and 24 is 40 plus 5 is 45. So then take my common factor of 5 out, giving me 5x squared minus 30x minus 6x plus 9 equals 0. My writing and my brain were in a time lag there. And then factorising further, we're looking for two numbers to multiply to give you 9 and add to give you minus 6. So that has to be x minus 3, x minus 3. So the answer to this is x equals 3. And because there's only one solution, then that means that the line is a tangent. Since there is only one solution, the line is a tangent to the circle. And to find where they meet, we know that they meet at 3 across, but we need to use our equation for y to find out where they meet. So, and they meet at, so y equals 2x minus 4, and we know that x is 3, so 2 3's minus 4. So that's 6 take away 4, so that's 2. And they meet, the coordinate they meet at is 3 across and 2 up. And that's answered our question. Number 4. Find the possible values of k for which the line x minus y equals k is a tangent. Okay, so again, we're going to start by subbing it in. Now it's up to me whether I change that to x equals or y equals. It's going to be easier to add a y to both sides and make it x equals and then sub in for x. So we've got x minus y equals k. So adding y to both sides, x equals k plus y. So then taking my equation for a circle, which is x squared plus y squared minus 2 equals 0, and subbing in that value for x. So k plus y squared plus y squared minus 2 equals 0. So squaring the first thing gives me k squared. The product of k times y is ky. So if I multiply that by 2, I get 2ky. And the squaring the last thing gives me y squared. And then I've got another y squared and a minus 2 equals 0. So I'm going to tidy this up now, but I'm looking at it and it is a quadratic. So I want the y squareds first, then the y's, then everything else at the end. So I've got y squared and y squared, so 2y squareds. Then the only coefficient of y is this here, the 2ky. So that can go next. And then everything else is the c, is the number at the end. So we've got this k squared and this minus 2. Now I'm going to put it in brackets just because I know I'm going to be using that c value later on, okay? So I'm going to call it k squared minus 2, and I'm going to keep that as that's my separate c. So in order to work out when it's a tangent, so line is a tangent when b squared minus 4ac equals 0. Okay, so our a here is 2, because we've got 2y squareds. Our b is 2k, because we've got 2k times y. And our c is everything else, k squared minus 2. So subbing that into b squared minus 4ac gives me 2k all squared. Be careful with that, you want to square the 2 and the k. Minus 4 times a times c. And we want to make that equal 0. So 2k all squared is 4k squared. Then I'm doing minus 4 times 2 times k squared is minus 8k squared. And minus 4 times 2 times minus 2 is plus 16. So 4k squared take away 8k squared is minus 4k squared plus 16 equals 0. So subtracting 16 from both sides, minus 4k squared is minus 16. Then dividing both sides by minus 4, k squared is 4. And then taking the square root of that, k will be the square root of 4, which is 2. But remember, it could be plus or minus 2. So there are two values here. So then to finish that off with a wee kind of summary, we would say that the line x minus y equals k is a tangent to the circle when k equals negative 2 or 2. And that's our summary answer. Okay, and here we have an example where we're asked for the straight line and it cuts the circle at 2 points. We need to find the coordinates and then we need to find the equation of the circle, which is AB is the diameter. Okay, so a fair bit to do here. So first of all, to find the coordinates, we're going to have to do what we've been doing before and sub that straight line into our circle. So taking our 4y equals x plus 20. And I'm going to change that. I'm going to divide through it by 4 to give me y equals a quarter x or x over 4, whatever you prefer, plus 5. And I'm going to sub that into my circle equation. So that gives me x squared plus y squared will be a quarter x plus 5 squared minus 8x minus 12, a quarter x. Now that x is not in the bottom, it's a quarter x. I should make that clear. It's not in the bottom, it's beside it. A quarter x plus 5 minus 16 equals 0. So that's x squared plus, so squaring a quarter x, we square the top, 1 times 1 is 1. We square the bottom, 4 squared is 16, and the x squared. Twice the product, so 5 times a quarter x is 5 over 4x, okay? So we have 5 over 4x, and if we are doubling that, then that becomes 5 over 2x, okay? So 10 over 4, which is 5. So 5 over 2x, then squaring the last 5 squared is 25, minus 8x, then minus 12 over, divided by a quarter is minus 3x, and minus 12 times 5 is minus 60, minus 16 equals 0. Okay, so fractions. So let's look at this just now. We've got x squared and a 16th x squared. So we can write x squared as 16x squared over 16. And that would cancel out. So that, if I'm adding those together, I get 17x squared over 16. So those are dealt with. Then I've got 5 over 2x minus 8x minus 11x. So what's going on there is I've got 5 over 2, and I find it easier to think of that as a decimal. So 5 divided by 2 is 2.5 minus 11x. Okay, so that's what I'm doing. So my answer is a negative. And then the difference between 11 and 2.5, so 11 take away 2.5 is 8.5. And 8.5 as a fraction is 17 divided by 2. If this is a calculator paper, you're laughing, but I'm not using a calculator in case it's not. So 25 take away, so I've done that, there we go. So 25 take away 60, take away 16. So 25 take away 60 is negative 35. Take away another 16 is negative 51. So it looks a bit better. It's still got horrible fractions in it. So again, take out the common factor, and we can use this to our advantage here. If we take out the common factor of 17, then we're left with x squared over 16 minus x over 2 minus 3. Now, you probably could factorise that, but I think it's easier to take out all the fractions. So what I'm going to do is I'm going to multiply this bracket by 16. And in order to keep this the same, I'm going to take out a common, like this, a 16th, if you like. So I'm taking out a 16th, which means that I've got to write that as 7 over 16. And what effect that has in the bracket is everything gets multiplied by 16. So that becomes x squared minus 8x minus 48 equals 0. And I find that easier to factorise. But you probably, yeah, you could do the factorising of it before you did that. That might work. In fact, it would work if you prepare. You would just need to use your grid method. So we've got x, and the numbers that multiply to give you 48 and add to give you minus 8 are minus 2. Oh. So minus 12 and a plus 4. Oh. Plus 4. Okay, so yeah, minus 12 plus 4 gives you 8, and when you multiply them together, it keeps the negative 48. So my answers here are x equals minus 4 and positive 12. So those are the x coordinates of A and B. So I need to find the corresponding y coordinates. So when x equals minus 4, y equals, and I'm going to use this formula up here, a quarter of negative 4 plus 5, which is a quarter of negative 4 is minus 1 plus 5 is a 4. So that gives me the coordinate negative 4 across, 4 up. And then when x equals 12, y is a quarter of 12 plus 5, which is 3 plus 5, which is 8. So that gives me the coordinate 12 across and 8 up. So it doesn't matter which one's which. I'm just going to say that's A and that's B. So now I've found my two coordinates, I need to do part B. So, and now for part B, we're now asked to find the equation of the circle with AB as its diameter. So if AB, what do we need for a circle? We need the centre and we need the radius. So if we've got AB as being the diameter, then that means that the centre of the midpoint of AP will be the centre. So the centre will be our midpoint of A and B. So I might just write A and B up here actually before I write the centre. So I've got that. So A is negative 4 and 4, and B is 12, 8. I just like to have it right there. So the centre is the midpoint of these. So we take the x coordinates and average them, and the y coordinates and average them. So minus 4 plus 12 divided by 2. And the y coordinates 4 plus 8 divided by 2. So that gives me minus 4 plus 12 is 8 over 2 is 4, and 4 plus 8 is 12 over 2 is 6. So the centre of my circle is 4 across, 6 up. The next thing I need is I need to work out the radius. So the radius goes from the centre to either A or B, or you can work out the distance from A to B and half it. It's up to you. So I'm going to do the different, I'm going to do like, what will I do? C and B. Okay, so the distance, so the radius equals distance from my point C, I'll call, so C is for 6 to B. I'm only doing B because it's not got a negative. I don't know why I picked it. So I need to pick one to be x1, y1, and another to be x2, y2 to use my distance formula. So the distance formula, remember, is x2 minus x1 squared plus y2 minus y1 squared. Okay, so x2 is 12 minus x1 is 4 squared plus y2 is 8 minus 6 squared. So 12 take away 4 is 8 squared. 8 take away 6 is 2 squared. So that is 64 plus 4, so the square root of 68. Now, for this bit here, I could go simplifying that, but because my formula it includes r squared, which is going to be 68, I'm not going to bother doing that. So I'm just going to quickly pause and rub out. The final bit is the equation, and remember we've got the centre of 4, 6, and we've got the radius. So I'll just summarise that. So our centre is 4, 6, and our radius is root 68. So to find the equation, we will use x minus, so there's a and there's b, x minus a squared plus y minus b squared equals r squared. And we'll just leave it like that. If you wanted to, you could multiply it all out, but it doesn't ask for it in general form. So I think that's enough.